All right, welcome back, generals, to another. Let's fix the generals to zero how to make the best game ever. No? Last video we did look at dia to dumper or PDB dumper, which stands for Program Database Dumper. Yeah. So we have a plan. Yeah, we have a vision. So you do similar to this procdb save symbols config program database pdb exe Okay, so let's first get back to our branch here. And then we add some new files here. What do we want to call it? PDB parser. PDB reader. How about that? PDB reader. Then we do a CPP. Then we go to CMake list, and then here we append. So we have git info executable efmp. So we do pdb reader.h and cpp. Okay. Then we compile that, and that fails. Okay, why? That fails. Well, something I must have done wrong. I didn't do much. Why is this failing? I just added a file. Okay, how about... Good, how about we remove it again, see if that compiles. Fails. Huh? I don't understand. Build, rebuild solution. I don't get it. What did I break now? I didn't change anything. I don't know. Somehow it doesn't want to compile anymore. Why? I don't know. Just doesn't work anymore. Okay, let's stash this. Let's go to main branch. Let's try to compile that. Okay, that also fails. Let's get back to this. Stash pop. Okay, what now? I don't understand. Why it's now suddenly just fails. Okay, let's close Visual Studio. Let's open it again. Open with Visual Studio 2022. Build, rebuild solution. Doesn't work. Could it be because we, in the meantime, we worked with Visual Studio 6 and that somehow messed something up in Visual Studio 2022? Because why not? Checking build system. The system cannot find the path specified. It's probably looking for CMake. And I moved CMake. Could that be the problem? Let's open this CMake again. Not sure. Okay, let's unassemblize. Unassemblize. Solution. Okay. Configure. Okay, build, rebuild. Aha, there we go. Okay, I think the problem was that we moved CMake physically and that needed updating. I see. Okay. That's fair. Yeah. Oh, shit. Yeah. Okay, so I think the goal for this session will be just to set up the foundation for the DR2 codes, see how far we can get without going into the details. Just get started with it. Yeah. Okay, how about we stop the debug session here? I'm tired. But we have to work. No work, no progress. Always work. Until we die. I can stop working when I'm dead. Alright? Yeah. Then I can take a nap. Oh, wow, the compilation is slow. Hooray! Good. So our new files are here. They are all empty. Let's update here the errors in these headers. Unassemblize is the name. Disassembles. Okay, so we copy this to here. And then we put the same here. Class to extract symbols from PDB. Extract relevant symbols from PDB. PDB files. Let's make this PDB. How do we get this here? Well, add word to dictionary. How about that? Okay, so this includes PDB reader or PD breeder. Yeah. Okay. Unassemblize. Do we need to put it anywhere else? Yeah, here. Okay. Good. Okay, let's create a new commit where we just fix the headers. Fix file header texts. Fix source file header texts. Okay. Good. So we need to read PDB. Well, maybe we can take the same shell here for starters. Dump PDB, dump sims, dump symbol stored in executable, yeah. Dump symbol data stored in P file, config file. Dump symbol data. I think this option is redundant. Like if you execute dump sims on a PDB, then you don't need this option, right? You just recognize it's a PDB, and you go through the PDB line of things. So I think this is useless, but there's still exa here. Executable. Database. Okay, let's create a class. Wait, first we need namespace. So we got the namespace here and here. So it's class excuse my formatting. C, well, just PDB reader, PDB reader, and yeah, that's it. And then we say here in the executable PDB reader, PDB reader. So I got to main dump sims. We say dump symbol stored in the executable or PDB to the config file. Yeah. Dump sims. Dump symbol stored in an executable or PDB to the config file. Yeah. And then we do, so we have config file here. How about config? Auto output. How about we also introduce concept of auto config? Because since we will have different inputs, different, like at least two, like Thyme and game dots, then it makes sense to just like automatically choose a config file for it. Auto config. When config is set to auto, then config name is chosen for input file name. Yeah, we do it similarly. So then here we do this and we put it to auto. Yeah, config file, actually here auto. Let's put it here. Yeah, format string. Config JS, good, auto. Program S. Output. Default is auto. What happened? The fuck? Default is. Heh? What's happening here with the formatting? Auto. Default is auto. Is disassemble written correctly? Disassemble. It's written with one S. Disassemble. And this is hexadecimal. Configuration file describing how to disassemble the input. Default is auto. Configuration file. Do we really need to say what default is? Default is auto. I don't know. Let's. Default is auto. Okay, so config file. Let's see. Why don't we also say here output file? Output file. A little bit consistent naming. Okay, so config file, where's it used? Config file, save config, config file, load config. Okay, load config. It can only provide one. That's okay. Right now. How about we call this inputs, input file name, passing inputs file, okay. I think here, for completeness sake, it's not really necessary, but we can also add this just just to clarify that empty file name is valid. How about we shorten this to input file? Okay. Print sections. Save config. That function. Okay, so the problem I'm seeing here is like if we work with a PDB, then we cannot pass exe here. No? Exe. What is this doing with exe here? Let's see. Exe disassemble function. Disassemble func. Disassembler was consistently written wrong. Okay. So the problem I'm having right now is like if we don't pass it in exe, how can it still go through this code? Like it can't. And it's not supposed to. It's not supposed to. Okay. Input file. Input file. Verbose. Passing input file. Okay, how about actually let's put a new function here. Void process executable. Yeah. And then we have another process PDB. Well, let's make it short. Process exe, process PDB. Yeah. And then we copy all this junk here. All this. We take it and we put it here. Now, obviously, we need to config. Okay, here regarding config file, let's put a let's put here if config file is autoconfig, then config file 2 config file 2 std string config file 2 config equals config file. So when it's autoconfig, then we build input file input. Where's input file? Ah, it's down here. Okay, let's put this down here. Input file config file 2 config file input file plus config.json. Okay. So it will automatically build like thyme.exe.config.json or game.dat.config.json, right? So that's good. So let's label it ends up being program.exe.config.json. Yeah. Maybe we just like this program. Perhaps we can also add this hint here. Program.exe s, and here we say program.exe dot function name dot s. Yeah, that helps understanding, I guess. Okay, we need to more work done here. Okay, so if we need a function to C++ get file extension. What is the simplest way to do this? Okay, this is C++ 17. Get file extension. This one looks good. Find last of dot. Yeah. Yeah, this looks good to me. Remove characters and let's put here file ext. Remove characters. Get file ext string file name. File name, find last of. Find. Okay, I see there's potential to optimize. Find last of. Size t, pos equals this, because it's doing search twice unnecessarily. That's stupid. Const pos +1, otherwise return empty string std string, or I think simpler, we just return like this. Yeah. Okay, this should do. So we say here input fire. Actually, get file next. This would actually be even easier. Let's see. Const char. But then we need to. Yeah, I think it's fine. Like we could also have like get file ext from a const char pointer and then return a const char pointer to the file ext without constructing a new string. But I think this is simply enough. Let's go with this. We're not so concerned about high performance with this function. Oops. But what we can perhaps say is input fire. Input fire. Okay, std string. Actually, input fire. Outputs. Input fire. Inputs. Let's put input file str. Input file, okay. And then we say config file 2, we can also make str. Let's make it here config file 2. then we say if config file equals autoconfig, then we do this. I think that's easier. Yeah. Config file. Okay, and here's str. And here we can use now this. Okay, and then we say here std. Let's do that before. How about that? Here. Std string input file ext. Then we do get file ext input file str. Okay, and then we put this one here, and then so we have let's just do down here if we need a case insensitive compare. C++ case insensitive compare. To lower. Yes, the equal begin and each are equal. How about we create a new file? Let's get this to compile first. So right now we will call process exe, right? And we need to pass a bunch of arguments. We pass verbose, which is probably a bool. So, or is it not? It is. So, executable, let's call it exe file. Process exe. So we need an input file. Input const char. How about we do it here? Input file with string. Const std a string input file. Put a .cstr. Then we have here. This one also takes. Okay. .cstr. Okay. So apparently these all take .cstr. All right. Okay. Okay, then we do a const std a string config file and output file const std string output file. How about we take these things, we take this and we put it up here. Okay. So we have print sex. Okay, boy. So we have print sex and dump symbols. And what else do we need? Section name we currently don't use. Section name. Let's do const char section name. Oh, there's more. This should be a class, I think. Let's create a or for starters, let's make a struct exe options. I think exe options. Let's put here all this. But that's also okay, input file, config file. How about we call this exe file? Output file. Then we do std string section name. It's unused. And then these things. Both. Let's put some defaults here. False, dump sims, false, false, exe file. Well, has no default. Config file, config.json, output file, program.s, or let's keep it empty. section name dot txt. Okay, I think that's fair. Then we do here exe options, const options. Then here we do, yeah, I think we do nothing. Let's call this O for really short. O.exe file, O.verbose. What is format string? Format string. It's null pointer. Oh. Okay, a city string, format, string. What is format? Does it have the default? No. Format. If o.format.empty, if not empty, .cstr. Oh, what is happening here? Why? Don't do this. Don't autocomplete. Format. O.format. O.format. Input file. Exe file. O.format. O.verbose. O.print6. Dump sims. Config file. Then we need a start address. What is this? You in this. Start address 00. Process exe. Returns an int. Returns 0. Oh, verbose. Exe. Why is this error here? Oh, format.cstr. Oh, that, this. Input. Exe. This is name dot function name dot s. if o dot output file dot empty output file name how about we do let's do keep empty. Let's do here keep empty. If o output file dot empty keep it empty. Custom let's do here custom. Okay, this is exe file name dot cstr file name output file cstr. Okay, what's the problem here? What does it take? Oh, it's a format, right? All right, formats here, formats. Thank you. Let's call this. How about we just change this to? Yeah, no. Let's rename this to formats str. Okay. I think this will work. Okay. Then down here we need to create a exe options. So if str case compare config inputs amplify xt is exe equals 0. That's 0 equals this. And then here we need the .cstr. If that. And then we do exe options. And then we need to fill that. And then we do process exeo. And then else if this pdb Then we do pdb options o process pdb o and else wait, so we need to also return else return 1 for error. Okay, something is wrong here. This good, that is looking promising. Yeah, so then we also need a struct pdb options. Let's call this pdb options, and there we need I don't know. I guess we don't need this. We need an output file, a config file. Do we need a config file? Oh. I think for starters, we just want to write out a config file. So let's go with this. We don't need a section name. I don't think we need this. Print sections. Yeah, I guess. I don't. Yeah, maybe dump sims. Webos. Okay, I think this is our starter set. And then we do here int return 0. Return 0. It looks like this function can only return 0. Okay, well, it's fine. PDB options or const, yeah. Okay, this should work. Process PDB. Okay, let's see if this compiles so far. Some error. Section name .cstr. Okay. Config.json. Section name. Output. Okay, so here we need to fill the options, or let's copy this. So we simply need to delete all this junk here and this junk. And then we do here, select this dot exe file is equals input file str, config file is config file str. Output file is output file. How about we move this to the other place? So we have here input file. We do SCD string output file str output file, yeah, output file, and then we say here if output you delete this. If output file str is auto, then to program so this is, all right, let's call this input dot fill. Well, let's call this program.exe. Yeah, I think that's okay. Get program.exe. And we do auto output. But it won't work here. Well, config file. I don't like that we, for one thing we pass auto and for the other not. I don't like this. Section name. How do we do it? Output file. I guess we simply do it. If output file str is auto output, program.exe s. So this will be input. So the input file plus s. Then we remove this here. Okay. Okay, I think this is all right. So output file str. Section name is section name. Format string. Start address. End address. Yeah. And so on and so on. Print 6 and dump sims and verbose. Yeah. Process exe. So and here we say PDB. Yeah. Okay, and PDB options. Oh dot. Let's go to it here. All right. Da, da, da. Da, 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 da. Da, 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 da. Okay, and here is PDB options. Well, how about we still name this input file? Input file. That's at least consistent here. Input file. Config files. Config.json. Yeah. Okay. PDB options. Okay, dot input file equals input input file str config file this. Okay, good. I think this works. So I think now the main function is a little bit cleaner and a little bit simpler, as we just pass on, we process a little bit our inputs and then we pass it on. And then in here we can now clean up here to if empty, keep it empty, else if else we simply file name is output file plus this, so this will be effectively program.s.symbol.s, right? I mean, it's a little bit convoluted, but yeah, who cares? Okay, here we need this and this, and something is not quite right here. We are missing, something is wrong here. We are missing some indentation. Maybe here. Oof. Maybe it's one too much. That could be, yeah. Okay, so it's file name, keep it empty. How about if not empty? That's simpler. If not empty, and then we do this. Yeah. File name. Okay, and down here we just pass this as is, and we can remove all this, right? Yeah, and now this is also simpler. That's good. Process exe looks now a little bit more compact. Yeah, let's put the 0 comparison here to the front where we added. Not that it really matters, but I think that makes it a little easier to read. Perhaps. Maybe, maybe not. Okay, good. So we prepared everything to then start with processing a PDB file, given these options. So we have an input file and a config file, because we just want to dump config for starters, right? So it will be similar to how we do this. Process exe. Process exe. Process exe. There's one disadvantage though. Like if the PDB file was not ending with an actual PDB, right? It was just like, I don't know, it had a different name for some reason. Same for the executable. Oh, right. Game.dat, for example, is not ending on exe. So that already fails. Yeah, I didn't think that through. Dump sims. We can do here another option. No arguments. Required argument. Yeah. We make a copy here. We do input type t. Input type. And do const char input file type. By the way, here we have auto. Let's make this just one auto. Auto str. Let's take a copy of this. Let's delete this. Let's do output. An output is set to output file is set to auto, then output file name is chosen for input file name, yeah. And here, when config file is set to auto, then config file name is chosen for input file name, yeah. Then we delete these things here. Then we put here auto and auto here and delete this. Hold on. Auto str. Auto str. Config fire. We made a mistake here. Const char output file is equal this thing. Let's move the comments here so that the line is cleaner. There we go. When input file is set to auto, then input file, when input file type is set to auto, then input file type is chosen is chosen by file extension. So I think what we do is here std string. By the way, that what the hell is that? Yo, this is wild here. Oof. I have no idea what's going on here with these things. Like, what happens if we run out of characters here? What happens? Just stop adding arguments? Like, this looks so brittle. Ah, you can have numbers. See. Well, let's add a number here. Number 3. Case 3. Input file type. Opt arc. Break. The fuck just happened? Okay. Okay, so we can specify. We can specify that. Then we say here. Let's put, let's rename this to input type. Input type. Let's put here enum input type, and we have, let's put an enum class. We have exe and pdb, and so if output file, no, output type if str case, if 0 equals str, no. If 0 str compare input type auto str, okay, then we go in here and we say, hey, if pdb, so we say, like, what is the input type file? If it's here, input type, and if this compares to pdb, then we assume it is, then we don't assume, we just say here, that's input type type equals exe, if it's set to str, then we recognize here pdb, and we set it to type equals input type pdb, right? Otherwise, else if str compare as a case compare input type pdb, then this would be type equals input type pdb. Yeah. So we recognize it either from, oh, hold on, there's a mistake. Input file str dot cstr, this one. I need water. Okay. So if this PDB, then input this. If input type is PDB, then this. Otherwise, we just default to exe. Yeah, and then here we'd say if input type exe equals type, then this. Else input type pdb equals type, then that. Yeah. Else, well, that can't reach, basically. It's impossible. Good. Yeah, I think this makes sense. So basically, by default, it will always assume it's an exe. Unless you pass a PDB, then it recognizes it and passes it as a PDB. And otherwise, you can also overwrite. You can explicitly say it's an exe or a PDB. Hold on, we need to have as if. Well, it always defaults to exe, so no matter what you type. So if you would type input type equals Valhalla, then it would still default to exe, which I guess is fine. Or we say here else if this, if we want to make it correct, and we say here type equals, we can do here, okay, we do else. Let's be extra explicit here. So we put input type exe here, and then type not equals assign. So here, if it's, let's put exe here, and here's pdb. So here we put exe, and here input type pdb. Yeah. And then else, it will be unrecognized, right? Else unrecognized. Let's put it here, printf. unrecognized input file type %s exiting. So this is input type here, this return one. Yeah. So by default it's set to auto. When we pass it executable, if you pass it anything other than the PDB, it's treated as the executable. So game.dat is the executable. If we pass a .pdb file, then it will be treated as a PDB. But we can also overwrite this with explicitly writing out the input type, either as exe or as PDB, and then it locks that in. And if it's unrecognized, aka some gibberish that is not supported, then it quits here. Yeah. Okay, I think this will work, and I think it makes sense for what we currently want to do. Good. Then, yeah, I think this is this probably we will remove in the future again, I guess, because it looks like we don't really want that. But I think for now it's good to have because it allows us to dump like a whole lot of data and go through all the symbols and everything. So I will keep this here for now. Good. So then next we can actually process the PDB. Start with that junk. Before we do that, let's compile actually. It does compile. Okay, that's already good news. PDB exe options. We could probably move. We could move this a bit down here. Move it here. Move it here. Yeah, and these things here could probably be moved into some utility header. Yeah, dump function to file. Yeah. Okay, well, you can leave it here for print sections. Yeah, print here. Okay, then what do we do next? This one is written incorrectly. Yeah. Okay. Good. So the next step. PDB reader. So I guess we start with something similar to this for starters. Program database. Let's actually, for starters, update our this one here. So we have output empty. Yeah. Let's do debug. Okay, Thyme.pdb. Output. Okay, let's just put Thyme PDB, yeah, in here, and let's see if main works correctly. Yeah. So I put a breakpoint here. Right. What is this here? Good. So we have auto, yeah. Section name, okay, blah, 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 blah. Input file is Thyme PDB. Input file, Thyme PDB. Extension is PDB. Do we still need that though? We don't, so we can actually delete this. Or not. Hold on. Oh, hold on. We need to compare this PDB. Okay. Yeah. Let's put the breakpoint here. What is the problem here? It looks like antivirus always pops up as soon as I interact with one of these executables here. Okay, so we have the PDB, Thyme, yeah. Auto, okay. If config file auto, then config will be thyme.pdb.config.json. Ah, okay, but this is pdb config.json. Let's get a new function. Remove file extension from file name C++. File system path. No, replacing a file extension. Replace xt. Well, remove ext. We just want remove. Okay, how about we just do it ourselves? Can't find anything. So we have this get file xt. Let's do remove file ext in place. Do here voids. Let's put it up here. So we have s. Well, let's keep it file name. Let's stop the debugging. File name, pause, and then we do 0 pause. Otherwise, it's not return. File name equals file name substr, otherwise do nothing. Put this here, save. Let's also put here this file name substr 0 plus. I think this will work. So then we can use it here. Let's do a program config program.s here. We do here this plus this. Well, shit. Okay, we need to change. Let's not do it in place. Get remove file ext. Let's do s here. Const. Actually, no, not s. It's too unspecific. Pause. Okay, here return. Return. Otherwise, return file name as is, right? Yeah. Get. Okay. Okay. And here program get remove, then this, and here get remove. We also do it here, and then it will be this output file here. Good. I think this will work. Okay, then let's run this, compile. And again, we got the goddamn virus scan here. Good, so input, yes, auto. Yeah, okay. So this should now become thyme.config.json. Yes. And this should become thyme.s. Yeah. And this should become pdb. Yeah, there we go. Good, PDB. And then we should go here into PDB. Yeah. Okay, this works. Great. Good. Then good. Then we got the starting code that is done. Good. Then next we need to worry about process PDB. Yeah. Process PDB. Good. Sorry. We need to. What do we need to do? We need to. We need to. What's the time? Well, almost 2 hours. Again. Yeah. It would be nice to take a short break. I think we got a little bit of work done, less than I hoped we would get done. I thought we would get more done of the PDB reader, but we were so busy here with the main function that didn't really happen. Yeah. We are slow, very slow. Yeah, so break would be good. A short break, yeah. Good, let's take a short break. But I still want to do one more session today to get a little bit done in the PDB reader, to get some of the boilerplate code done. Yeah, and then I think that would be a successful day. Good, I will take a break. We almost made the 2 hours again. Maybe we wait for, for the 2 hours. Let's see what was written here. So Thompson says, what's in Microsoft PDB repo can also read the old format PDBs. It's a matter of choice, ease of use, I guess, which code to try to use. The to dump isn't from Microsoft repo, it's inside VS install dir. I found to dump first, but maybe there's a better API for getting info from PDBs in the MSPDB repo. dir is pretty convoluted and strange. For instance, I can't fetch file hashes like that. I need to query everything. Without the query, it has hash entries as null while file names to work. It's all very weirdly designed. Of course, file hashes aren't of much use. Just a technical curiosity, I guess. What I'm talking about is PDBs contain hashes of the files involved in building the binary -sf, and my tool dumps those if they're this is PDB version 7 feature, so VS 7 plus anyhow. PDBs also contain what is referred to in DIA as contribution maps. Contribution maps have info on basically the code and data layout of the binary, which means size, hash, object it was linked from, all sorts of other info. Our interest is hashes. Provided we can compute the same hash in for code in the 0-hour binary, we have a direct and clean way to check for matches. Huh? Why hashes? What does a hash do? Huh? Like unassemblize does nothing with hashes. It's only assembler code. Our interest is hashes. Okay, let me reply to this. Question mark. Provided we can compute the same hash in for code in the 0-hour binary, we have a direct and clean way to check for matches, mismatches. Yeah, but the hash has a problem. It cannot tell you what is mismatching. So if we make a hash of a big chunk and we just say, oh yeah, the hash is mismatching, it's fast, sure, but it doesn't, like, if it's mismatching, it doesn't tell me what is mismatching. It just says, okay, this whole thing that the hash describes is mismatching, but then I will be left wondering, oh, what exactly? So I mean, if we talk performance and we want like really fast comparisons for like absolute correctness on high level, and like instead of comparing on binary on assembly level, then yeah, sure, have a hash to speed up, but it shouldn't be the foundation of the comparison, in my opinion. So I don't understand what the interest with hash is. For performance, absolutely, but as the smallest unit, I don't see it. I don't know, makes no sense. My D2D fork also has another feature added, being able to compare types between two PDBs. Not of use right now, but maybe later. Hash ASM, yeah, but slight catch, the hashes in PDB are from objects. The assembly in the object has relogs as zeros. So we would need to build a relog database of sort for the final binary. I partially have a way to gather the info, not fail proof, but something at least. Okay, I have no clue what's going on with the hashes. For now, I will try to build something that allows us to build the same kind of assembly blocks for original and Thyme. Yeah, if there's some way to use hashes in between for performance, whatever, okay, but I don't see it, like, because we would like to see, if this function is mismatching, what exactly is mismatching? It's this assembly instruction add line 25 of 50, yeah, in the middle of the function. And then ideally it would also tell us, okay, this assembly line 25 refers to C++ code line 7. Yeah, this line is mismatching. So that would be my vision for this. So I don't know what the interest here in the hashes is. It sounds to me secondary, but I don't know. Maybe if he brings up his example or some, I don't know. I haven't seen it. Good. Now we are above 2 hours, right? Yeah. So 2 hours too. Okay. Then I will take a break now, and then yeah, hopefully we can get a little bit more things done. All right. Then I wish you a great day or night. Until next time. Goodbye.